So for the homework help for today, right, we should be looking at page 1 of the week 5 problems. And remember, we're just getting a little bit more into exponents over here. So, for example, right, we want the exponent to be 1. So we got to think about how to make the exponent become 1, right? And the only way that we know how to get rid of this is we could take it to another exponent, right? Because the exponent of an exponent, and that's when we multiply. So we got to think about 8 times what is equal to 1, right? So we got to find the reciprocal of 8, right? Let's maybe add that in here, right? So for instance, let's see here. We could say 8 is the same as 8 over 1, which becomes where's that arrow? Which becomes over 8. All right, there we go. Right, so we got to think about if we multiply, right, 8 times 1 over 8, then they're going to cancel out, right? Because the 8 cancels out the 8, the 1 cancels out the 1. The other way we could think about this is, right, 8 times 1 over 8 will just give us 8 times 1 over 8 times 1. So it's 8 over 8, or just 1, right? So remember, the exponent to an exponent will multiply. So that's the only way we could get this to be 1, is to take it to another exponent of the 1/8. Just like this. So we have x to the 8th, right, in parentheses, and we're raising that all to the 1/8. And whatever we do to one side, we have to do to the other side. So since we take this to the 1/8, we have to take this to the 1/8. Right? And then remember, since, right, 8 times 1 over 8, right, like what we showed over here, is equal to 1, we just get x to the 1, or just x. And here, right, we're just using the rule where we drop the denominator and we put it outside of the root, like how it is here. And then, right, we could imagine that there's an exponent of 1 next to the 65536, right? But an exponent of 1 is redundant. So then we end up getting, right, the 8th root of 6,566, right? You might have to use a calculator on this. So I'm going to pull out my calculator at desmos.com. And then we're just going to say, right, pull up that root function, right? So this is the square root, right? But we don't want the square root. We want the 8th root. You're going to have to go here. I think it's under miscellaneous. Yeah, where you see under miscellaneous, you see the square root with the little n. That means you could type in 8 here and click on the inside, and we could put 65,536. And we see that it just equals 4. So there, we're done with the first problem. So moving on, the next problem, right? So keep in mind that there's 2 types of problems here. There's the first type where the x is in the denominator. And then there's another type where the x is, there's one where the x is in the base, like it is here. And then the other type of problem is when x is in the exponent, like it will be for the third example that I'm going to go over with you. So, right, this is another one where x is in the base, right? It's just like here. The x is the big number. It's not small and above. So there's no x in the exponent, so we got to do this the same way as how we did this. The only difference is we got to make sure that we have x alone. So we got to get rid of everything next to the x, right? The only thing next to x is this -5. So what we're going to do is we divide both sides by -5, right? We put -5 on the bottom. We added a -5 on the bottom. We'll really multiply, right? That makes these -5 guys cancel out. And now we have, right, x to the -3 equals 25 over -200. All right, so the next thing, right, is I'm going to do this in, you could do this in one big step, but I'm going to do this in 2 small steps, right? First, let's just get rid of the negatives here, right, because I don't like negatives. So what we're going to do here, right, is remember a negative times a negative will be positive. So what we are is we're, right, because that's the only thing we could do with these exponents is multiply it by numbers by raising it to another power. So I'm going to raise it to both sides to the -1. So that way, right, this will be x to the -3 times -1, which will be +3. And this, right, it's a fraction, and we remember raising it to the -1 just means that we got to flip that fraction upside down. Find the reciprocal, right? So remember, -3 times -1 gave us +3. And this fraction, right, all I did was flip it. And now that's actually kind of convenient because -200 over 25 is, right, think about how many times does 25 go into 200? Right, well, we know 25 goes into 100 4 times, so it goes into 200 8 times. We got a negative divided by a positive, so it is -8. All right, so now that we're at this step right here, right, where the only thing left on the left side is x to an exponent. Now we could do raise it to another power, right? We got to raise it to that fraction. We got to think, what's the reciprocal of 3? Just like how the reciprocal of 8 was 1 over 8, the reciprocal of 3 will be 1 over 3, right? 3 times 1/3 is 1, right? So, oops. That should be a +3. So we have, right, x to the 1/3, right, times 1 over 3 equals -8 to the 1/3. Remember, 3 times 1/3 just gives us 1. X to the 1 is just x. And we did the same thing where we dropped the denominator and put it outside of the root, converting that fractional exponent to a radical expression. And we know what the cubed root of 8 is, right? What number times itself 3 times is -8? Well, we know 2 times 2 times 2 is 8, so -2 times -2 times -2 is -8. I'm sorry, -2 times, yeah, it's -8. All right, so now is the third type of problem. So you see here, the x is in the exponent. The x was in the base. The unknown variable is in the exponent. It's small and little. But here the unknown exponent is in the base. It's normal size and in the line. Right, this x is small and up above. All right, so for these problems, the idea is we just want to make one side, right, look exactly like the other side in terms of the base. Right, so is there a way how we could write 4 as 2 to a particular power? Right, so we could write 4 as, right, 4 is the same thing as 2 squared. Right, so now we see that both sides have a base of 2. We have a 2 here and a 2 here. So it's just like we could just think this exponent has to equal this exponent. So we say 4x minus 1, right, this exponent, 4x minus 1 equals this exponent, 2. And that's all you have to do. So as long as you could get one, as long as you could make them into the same base, right, you just say one exponent equals the other one. And then we solve this like we normally do. We add 1 to both sides, right? Make these guys cancel out. So then we get 4x equals 3. And then all we got to do is we got to divide by 4 on both sides, right? Make these guys cancel out. And we just get x equals 3/4. All right, so moving on, right? Remember, that was problem 12. So you guys need to do, right, 9, 10, and 11. Right, and so looking at the week 5 problems, right, we just did 7, 8, and 12. So you guys got to do 9, 10, and 11. I'll give you a hint. 10 is a special case because there's only one exponent that will ever give you an answer of 1. Let's think about 9, right? 9, where's the x? Is the x in the base? Is the x in the big number or the small number up above the exponent? X is going to be in the small number up above, like it is here, right? So 9 will be like 12. And then you guys still got to do, right? 10 will be special. And then 11, right? The x is big and below. So 11 will be like 7 or 8. And we're going to do number 13 next. And then you guys will have to do 14. All right, so we have these steps written out from us, and we got to think about which one of these steps is wrong. So remember, just like what we did here, how we had to move everything else to the other side first, right? Everything next to the x. Oops. Now we got to move everything outside of the parentheses to the other side, right? Because this 6 is only attached to everything in the parentheses. So, right, the first thing that we do is we divide both sides by 4, right? So that makes these guys cancel out. We could pull out our calculator. Right, make sure that 1392 divided by 4 is 348. Right, so if I'm going to say 1392 divided by 4, yeah, that's 348, so we're good. So moving on here, what did we do here? So now that we have just something raised to an exponent equals a number. So now it's time where we get rid of that exponent. Right? The opposite, right? The reciprocal or multiplicative opposite of 6 is a 1/6. So we're going to raise both sides to the 1/6. Right? So we're just putting an extra set of parentheses around this whole thing and then raising it to the 1/6. This we're just raising it to the 1/6. Right, so now we could think that this 1/6 cancels out the 6. We just get x to the 7 equals the 6th root of 348. So then we're going to take out that calculator again. Let's check to see if the 6th root of 348 is equal to 56. Right, but here, right, we got to go to functions here, and then we get 6, 348. Oh, but it's not that. It's not 58. It's around 2.65. Right, so that'll change your answer. So then, right, so you're not going to get x equals 51, right? You're going to say minus 7 from both sides. You'll get like x equals negative 4.